Hi everyone, next up is lesson 5.3. So yes, we are skipping 5.2. So go ahead and just move right on to 5.3 on page 303 in your workbooks. Today we're going to talk about estimating quotients, and this is going to be pretty much the same thing that I had taught you when we talked about whole numbers. So it tends to be a little bit more difficult, especially if you're not familiar with your multiplication facts, because you're going to have to find compatible numbers, meaning numbers that can be evenly divided to estimate these. So let's go ahead and look at Unlock the Problem. It says, Carmen likes to ski. The ski resort where she goes to ski got 3.2 feet of snow during a 5-day period. The average, here's a key word, daily snowfall for a given number of days is the quotient of the total amount of snow and the number of days. Estimate the average daily snowfall. So it says you can estimate decimal quotients by using compatible numbers. When choosing compatible numbers, you can look at the whole number part of the decimal dividend or rename the decimal dividend in tenths or hundredths. So let's look at it. We have 3 2/10 divided by 5. Carly and her friend Marco each find an estimate. Since the divisor is greater than the dividend, they both first rename 3 2/10 as tenths. So if we think of it, what is 3 2/10? It is 32 tenths. You just essentially take out that decimal. It says Carly's estimate. 30 tenths is close to 32 and divides easily by 5. Use basic fact to find 30 tenths divided by 5. Well, 30 divided by 5 is 6 tenths, or written as a decimal would be 0.6. So the average would have been 6 tenths, or 6/10 of a foot. Marco's estimate is 35 tenths is close to 32 tenths and divides easily by 5. Use a basic fact to find 35 tenths divided by 5. Well, 35 divided by 5 is 7. 7 tenths as a decimal is 0.7. So the average would have been 0.7. Now, whose is closer? To me, I think Carly is closer because I think 32 is closer to 30 than 35, not by much, really only by 1. Would either of those be wrong technically? No, because they're both very close. If you remember what we did for compatible numbers when we divided estimated the quotient of whole numbers, we picked a number above and below and then picked whichever was closest, if you remember us doing that. So that's why they're kind of showing you this in the story problem. Let's look at page 304. Says when you estimate quotients with compatible numbers, the number you use for the dividend can be greater than the dividend or less than the dividend. Example, a group of 31 students is going to visit the museum. The total cost of the tickets is $144.15. About how much money will each student need to pay for a ticket? So we have to divide. And we're looking at this. If you remember when we did whole numbers, the book had suggested that we always start with the divisor first, not the dividend. So for me, I'm looking right away at 31 and I'm like, okay, well, it's definitely closest to 30. So I would definitely estimate 31 to 30. So that's what we have right here. And then I have to think, okay, what can I estimate $144.15 to be that 3 can go into it? So if I'm thinking about my facts, I've got 3, 6, 9, 12, and 15. Well, 12 is pretty close to 14 if we're looking at the first 2 digits. And 15 is pretty close to 14. It's actually definitely closer. So I'm going to go with 150. So if I'm looking at this, remember the power is a 10, so we can take a 0 for a 0. 15 divided by 3 is 5. So it'd be about $5 per student to attend. Now it says use a whole number less than the dividend. So this case, we would have went with the lesser of the two, which would have been 12, which in our case would be $120. So 12 divided by 3 would have been 4. So we now know it's going to be between $4 and $5 for the students to attend if we're just estimating. So as a parent, I would always just send them with more because you'd rather them have more than not enough. All right, let's look at numbers 1 and 2 down here at the bottom. 28 and 8/10 divided by 9. Well, to me, 9 is, I could leave it 9. I could do that. And I could estimate 28 to be 27 because 9 times 3 is 27. So we could do that. We could take 27 divided by 9 is 3. If we wanted to, we could have gone 30 divided by 10 equals 3, and we would have got the same estimate. So remember, estimates aren't exact. There is definitely some leeway there, but they have to be compatible for one and as close as you can get them. Let's look at number 2. So it says 393 and 5/10 divided by 41. So for me, I think, okay, that's a no-brainer. I'm going to go straight to 40. And I'm thinking, what's close to 393 that 4 can go into? So if I'm just looking at these first 2 digits, I'm thinking, okay, so 4 times 7 is 28. That's too far off. 4 times 9 is 36. That's closer. 4 times 10 is 400, and that would definitely get me an easy compatible set of numbers because we would take 0 for a 0. 40 divided by 4 would give me 10. If I would have chose to go with 9, I would have had 360 divided by, oops, not that, by 40, I would have got 9. So you can see, as long as they're within a number of each other, they're pretty accurate estimates. All right, so I think you get the point. It is pretty similar to what we have done in the past. If we look at our homework on page 307, you guys have 2 through 14 even. 2 through 14 even. So I'm gonna go ahead and I guess box in the red. The red will be for everybody. The blue is obviously always for the blue. So if you're only doing the even numbers, that means you're leaving out all the odds. Okay, so 2 through 14 even. Blue group, you're doing 2, 4, 6, and 8 only. Okay, don't forget about study hall time, 2 to 2:45 if you need any help. If not, then I will see you guys tomorrow.